NRC is a force multiplier for us. Basically, we at NordSpace, we have a certain amount of expertise, but that can only go so far. So bringing the NRC in helps us get the technology off the ground, helps us develop this composite manufacturing process here in Canada, helps us create these high-end, high-quality personnel-driven jobs. And for us, it's a pretty good Canadian story, a Canadian company working with a national research group and being able to work on these hard problems here in Canada, solve them, then bring it to industry, bring it to the public so that all Canadians can benefit from this project. For our flight vehicle, it is going to go through various load scenarios. It's going to be torqued, it's going to be compressed, put into tension, it's going to vibrate, it's going to want to rip itself apart. And that kind of drives a lot of crazy requirements on the engineering side to be able to build a rocket that can survive all these conditions. So we have to take care of like the fiber orientations, the design of the layers, and as well as the material and the manufacturing process from end to end. Problem we face with orbital launch vehicles is that they can be heavy to an extent, and we want to drop our dry mass as much as possible. So when I was at SpaceX, I got to see the implementation of lightweight structures, the idea of not having to build really heavy pressure vessels that have to contain high pressure inert gases, and being able to see the use of composites across the board so that we're able to decrease dry mass in general. And that's been an industry trend ever since the space shuttle first flew. The space shuttle had one of the first applications of doing space grade COPVs, composite overwrought pressure vessels. So it's a growing industry trend to start using a lot of composite structures because just for the business case alone, you want to drop that dry mass. So every launch company, whether you're SpaceX, Blue Origin, Rocket Lab, there is some implementation of composite structures, the use of COPVs, because the more you can drop your dry mass in general, the more payload capacity you have, the more payload capacity you have, the more missions you can run. The more missions you can run, the more money you can make. So we looked at stainless steels like 301, 304 grades, and we looked at aluminum 2000 series. And the challenges with those are specifically just manufacturing. Working with stainless steels is very well known, but it is quite heavy, and it kind of means that we are going to lose payload capacity given our vehicle configurations and our mission that we want to achieve. And with aluminums, we find that the manufacturing is very difficult. It's just as complex as getting into composites. So there is a trade-off that needs to be made in understanding. When we get past the challenge of producing at scale, producing at cost, then we'll be able to look at what else can we make. So we can make more complex structures such as thrust structures, interstages, and as well as working with the NRC, well, this capability and these learnings are now going to be spread out throughout Canadian industry. Whether you're in automotive, whether you're making composite pressure vessels for hydrogen tanks on trucks, whether you need to make more complex fuselages in one piece for the aviation industry here in Canada, that learning and all that work now has been put forth, driven by us, because we need to make these big load-bearing structures that are complex, that are going to experience cryogenic conditions, advanced loading cases, but giving our flight profile. And that will push the limits of our composite manufacture, push the limits of AFP, and that will drive basically us to solve many problems and address many concerns across the composites industry here in Canada. At NordSpace, we have the capability, the experience, and the knowledge, and the ambition to make sovereign launch happen here in Canada. And we want to accomplish that by bringing in-house these advanced manufacturing capabilities to continue growing our team, to build Team Canada, and we want to get to space.